Okay, this is the Kinematics Graphs worksheet, and we have a table of positions and time points. And if you're looking at the amount of change of position over certain amounts of time, you can see it's pretty consistent over the first couple of seconds. So we can say for the first 2 seconds, the dog has a constant 1 meter per second velocity. That's the amount of change over time. So it's moving 1 meter away from the detector every second. That's the velocity that it's moving away from the origin because the position is getting larger. If it's getting smaller, it'd be moving towards the origin or towards the detector. Then for the next 2 seconds, from 2 seconds to 4 seconds, the dog has a constant negative 2 meters per second velocity, so it's coming back towards the detector and even passing that detector or that origin. I'm going to say the detector is at the origin at 0.0 meters, so the dog is coming back towards that and then progressing through. Just imagine if the origin is the library at the school, you're coming from one building to another, and you pass right through the origin from the positive side to the negative side. Or in this case, from C hall to B hall. You're going from the good side to the other side. We'll just call it that. Using a number line to illustrate the dog's use a number line to illustrate the dog's motion. Well, we know the dog has the positions that it's going to cover is from -1 to, looks like, +3. So our number line needs to at least have from -1 to +3. I think the way that I've spaced things out, it'll end up going to +4, but make no mind, makes no difference. So our dog starts at position 1 meters, and he's going to move to the right to +3 meters, then changes direction in order to go from +3 to -1. So we'll just draw a couple arrows along our number line just showing from 1 to 3, and then underneath that I'm just going to go from 3 to -1. Just a different way to visualize it, nothing to worry too much on this. Create a graph of the position versus time for the dog. So if we're going to make a graph, there's certain things every graph needs. We need to label the axis with units. We need to have the same amount of spacing per numbers, so we can't make each box different values. So we need to be consistent in our spacing. It also needs a title. So the vertical axis is going to be position with meters, horizontal axis is time in seconds, and then our title will be position versus time. And then depending on the number of hash marks or squares or boxes or whatever, we want to get a good distribution so that our graph isn't all just in one little corner. I'm going to space mine out such that I've got 0 to 4 seconds, and then I'm going to do every 1, 2, 3, 4th line as a second. So each hash mark would be a quarter second. Then vertically, I'm going to go from, I've got +3 down to -3. Of course, I only had to go as far as -1, but I think this will still give me a nice spread out graph. So my dog is starting at position 1 at 0 seconds, and then we'll get to position 3 at 2 seconds. So my first line is going to be from 0, 1, and then go to 0.23. And then from there, they're going to go from position 3 meters to position -1 meters over a 2 second time span, 2 to 4 seconds. So that's my second line. During which time intervals does the dog move forward? The dog moves forward when it has a positive velocity, and that was from 0 to 2 seconds. That's when our slope was in a positive direction. During which time interval does the dog move backwards? Backwards is going to be a negative velocity or a negative slope, and that was from 2 to 4 seconds. What is the dog's speed? Now, speed is the same as velocity, just doesn't matter with the plus or minus, but it was 1 meter per second. And what is the dog's speed from 2 to 3 seconds? Well, we want to say -2 meters per second, but it did say speed, so we drop the negative, and we can go ahead and erase that negative off of there and just apply the 2 meters per second. What is the dog's speed from 3.5 to 4 seconds? Well, from 2 to 4, it was 2 meters per second as far as speed. So from 3.5 to 4, it is still 2 meters per second. Find the dog's average velocity for every time interval and fill in the following table. This is really easy because it had a constant velocity, so the average is the same as the constant. For the first little 4 second segments there, it's a +1 meter per second, followed by the next 4, -2 meters per second. Certainly this could be a lot more challenging than it is, but this is still just the first day of class. And so let's not overcomplicate things. Those were the slopes. We can go back and look at the slopes, but it was 1 and then -2. Create a graph of the velocity versus time. So this is velocity in meters per second on the vertical axis, time in seconds on the horizontal axis, and then our title would be velocity versus time. If you're doing graphs for the same data sets, just you're going from position to velocity to whatever, try to make your horizontal axis the same scale so that you can kind of just overlay it and be able to see the differences between the graphs. Vertically, it's going to be different because the values are different, but horizontally, it'd be the same time scale. So we're still going from 0 to 4 seconds. And then since our values go from +1 to -2, I just made my graph from +2 to -2 as far as the vertical axis for velocity. And then all we have to do is graph a value of 1 for 2 seconds, and then we drop down to a value of -2 for 2 seconds, just demonstrating at any point in time, what is the velocity? Well, we can look at the table or we could look at the graph. If you look at the graph, for the first 2 seconds, we need a graphed value of +1. If we look from time point 2 seconds to time point 4 seconds, we need to look at the graphed value and see that the graphed value is -2. So we're just going to drop this line down to -2 and then go across to a 4-second time point.